Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad Syafiq bin Maksud, and my method ID is MA19311 from section 4, and today I will present for introduction for lab 3, fluid friction. Hydraulic engineers often estimate fluid head loss in pipelines. Predicting flow via proposed pipe connection to reservoir at different levels may be beneficial. It's also critical to determine how much more fluid is required to double a pipeline's flow rate. Mixing at vents and valve and pipe wall friction create head loss. Local mixing at the fitting cause most head loss in short multiple connection pipes. In a long pipelines, steam friction will dominate. For the problem statement, overall energy loss is the total of a pipe system primary and minor loss. Viscous fluid and rough pipe wall cause high frictional energy loss. Because of friction, pipe pressure drop. The friction factor F describes pipe friction loss. Laminar flow are exclusively influenced by Reynolds number and pipe surface roughness. In turbulence flow, Reynolds number and pipe wall roughness impact F. Calculate F using the Moody diagram. For the objective, first is to get a better understanding of the mechanics of fluid friction in pipe. Second is to investigate the velocity of various diameter in various kind of flows. And the third one is to comprehend small and substantial friction loss in a pipe. Our scope of project is to learn about friction loss in pipe flow at the fluid mechanics lab. The test aims to discover small and substantial pipe loss and better understanding of friction losses.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad and I'm from Group 5 in Engineering Fluid Mechanics Lab. For this lab of fluid friction, I'm going to present about the theory. First of all, we're going to discuss about the fluid friction. What is fluid friction? Fluid friction arises when two fluid layers move in opposite direction, as shown in figure 2.1. The fluid friction occurs when the particles of the fluid apply a force to the surrounding particles. Some of those particles will start moving and some will try to pull them back. If there is a phenomenon of push and pull at the particle, we refer that as a fluid friction. Here is some example of fluid friction. Firstly, the wet surface between two thin glass plates, then drop object in the fluid, finally the friction in the pipe. The friction in a pipe occurs when a liquid flows through the pipe, and the friction between the liquid and the pipe wall causes the pressure, also known as head loss. In this lab, we're going to focus on the final example, which is friction in a pipe. If there is a friction in a pipe, we must consider the coefficient of friction. So what is the coefficient of friction? The coefficient of friction is the measurement focused on the resistance to motion at the surface between two surfaces of similar or dissimilar material. The equation 2.1 shows how we can get the coefficient of friction based on the friction force divided with the normal force. After that, there are two reasons why the engineers prefer a lower coefficient of friction in the piping system. Firstly, to protect the pipe from abrasion wear. Second, to prevent the pipe from corroding. After we consider the coefficient of friction in the pipe, we also need to measure the friction loss in the pipe. The friction loss in a straight section of a uniform pipe is known as a major loss, caused by the movement of fluid molecules between other molecules or the wall of the pipe. It is affected by the type of flow such as laminar and turbulent flow. After this, we're going to discuss about the laminar and turbulent flow in the friction loss in pipe. So what is laminar, turbulent and transitional flow? Laminar flow occurs when the fluid flows in parallel layers with no mixing in between them. For turbulent, it occurs when the liquid is mixed between layers and moving fast. For transitional flow, it is a combination of turbulent and laminar flow. The flow happens when the laminar flow is near the edges of the pipe and the turbulent flow is in the center of the pipe. There is the specific value for each of the flow. For example, for laminar flow, the Reynolds numbers should less than 2100. For turbulent flow, the Reynolds numbers should be between the 2000 and 100 and less than 4000 value of Reynolds number. For transitional flow, the Reynolds number should be more than 4000. And this is the example of laminar flow, turbulent flow, and transitional flow. Finally, we need to consider the friction loss in pipe using Darcy equation as shown in equation 2.2. Using the Darcy equation, we can calculate the frictional energy loss in a pipe based on the resistance caused by the friction and the speed of the fluid. Then the calculation focuses more on calculating the heat loss due to the friction in the turbulent flow. The equation 2.2 or the equation of Darcy focus on the turbulent flow only. So that's all from me. Thank you.
A very good day. My name is Vignesh with metric ID MA20019. I will be presenting to you our reports method and procedures. Firstly, our equipments. The equipments that we have used for these experiments are pipe friction apparatus, data acquisition system, sensor, elbow pipe, flow rate meter, straight pipe, 45-degree bend pipe, 90-degree bend pipe, and the control valve. The experiment should look like the figure in the slide. Moving on to the procedures. All the equipments were in place and the apparatus is ready to go for the experiment. There were two pressure sensors utilized as input and output. The pressure input was determined by the sensor with the orange tag, while the pressure output was calculated by the sensor without the sticker. It was confirmed that the pressure sensors are linked to the DAQ system. The computer's Darcy lab was connected to the DAQ system and the flow rate meter. The flow rate meter was used to automatically calculate the volume flow rate. When there is running water, the Darcy lab provides the input and output signals. The water pressure was controlled by adjusting the control valve. All readings and outcomes were documented and tallied. Step 1 till 9 was repeated for elbow pipe, 45 degree and 90 degree angles after the experiment for the straight pipe is done. For those who do not know what Darcy Lab is a software that helps us to solve complicated data acquisition and control scenarios easily and quickly. Module icons are displayed on the screen and connected with wires to show the flow of data through the system. Furthermore, a DAQ system is required to identify the system's connectivity. That is it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atifah binti Bazri, Metro ID MA19308. So today I will present to you about the results for the lab 3, which is the flow friction. This is the given data by our lecturer. The given data include about the straight part, pipe elbow, pipe bend, and pipe angle 45 degree. The given parameters here is the volumetric flow and then the measured head loss. Next, we have this is the straight pipe data. From the previous slide, we have the data which is the volumetric flow V dot and then the measured head loss. So the rest of it we calculate by the given formula. The flow speed here, which is we call as the velocity, we calculate by using the formula V equal to for V dot over pi d squared. Pi d squared. The d here is 0.02 meter. It's given. And then the Reynolds number we get from Re equal to rho Vd. Rho is the the density of the water over the viscosity. And then we have the Blasius pipe friction, which is F equal to 0.3164 over square root 4 of Reynolds number. It's referred to the Reynolds. And then we have finally we have the calculated head loss, which is H. We got from H equal to F dot L, which is the friction factor, dot L, which is the length. Length here, the given length is 0.8 meter, and then over D, the diameter, times V squared over 2G, 2 gravity. The V is the velocity. Then next we have the graph. The graph here, we compare the measured head loss, which is the given head loss, and the calculated head loss versus the velocity. We can see that the measured head loss here having a downward trend line, and then the calculated head loss is increasing toward the velocity. Next, we have the pipe elbow, pipe bend, and pipe angle 45 data. From previous slide, we know that the volumetric flow and the measured head loss is given, and then the flow speed or velocity using the same formula like the straight pipe, Reynolds number, loss coefficient, we get from the graph given in the report, and then we have the calculated head loss. The calculated head loss here is quite different from the straight pipe, which is we using the formula H equal to K V squared over 2G. K here is define the loss coefficient, and then the blasius pipe friction using the same formula. And lastly, we have the equivalent length. The formula is LE equal to K, also the friction, times a D over F, which is the diameter. Diameter here is D equal to 0.1017 over the friction. And then next we have the graph. We also compare the measured head loss and the calculated head loss versus the velocity. This is for the pipe elbow. The trend line it have the same trend line, which is increasing toward the velocity. And then this is the measured head loss and calculated head loss versus velocity for the pipe bend. And finally, we have the graph for the measured head loss and calculated head loss versus velocity for pipe angle 45 degree. The value for the measured head loss for the pipe angle is very small, so the graph is not very sure that it having the increasing trend line. And then that's all. Thank you for hearing me. So now let's proceed to the discussion. Thank you.
My name is Muhammad Aiman Chukri bin Muhammad Safri. My number metric is MA 283. Okay, this is a discussion of fraction losses in pipe. For the next slide, this is question 1. The question 1 is explain how the strain gauge sense the pressure. It transforms force, pressure, tension, and weight into an electric resistance change that may be measured. Stress and strains are produced when external forces are applied to stationary objects. Next, internal resistive forces of an item are characteristic as stress, and displacement and deformation are defined as strains. The strain gauge is one of the most essential sensors used in electrical measuring techniques for mechanical measurements. They are used for strain measurement, as their name implies. Tensile and compressive strains are characterized by a positive or negative sign in the technical strain. As a result, strain gauge may detect both expansion and contraction. Okay, for the question number 2 is what would happen to the head loss if the diameter of the pipe is decreased and the length of the pipe is decreased. As we know, when the diameter decreases, then the head loss of friction will increase. And when the length of pipe decrease, and then the head loss of the pipe also be decreased. And question number 3 is, what are the two types of energy loss typically associated with pipe flow? From your experimental results, which one is the most significant loss of heat incurred by the fluid flowing along the pipe? Two types of energy loss typically include flow through a pipe network, major loss and minor loss. Major loss are induced by the viscous effects of the medium and the rawness of the fluid flowing, resulting in significant losses. Next slide is question number 4. How can you find the values of minor loss coefficient from your experiment? In addition to skin or friction losses in pipe flow, fittings, wall progress and rapid expansion or contraction, and interest and exit effect all contributes to modest loss. There is no explicit theoretical method for determining these tiny losses because the flow patterns involved and fittings are highest, complex, and vary from one manufacturer to the next. Typically, losses are assessed empirically and associated with pipe flow parameters. The head loss through the fitting or wave is normally represented as a ratio of the velocity head of the attached piping system to the minor loss. The loss coefficient for the fitting or wave is the resultant ratio. This is the part last for my slide. This is question number 5. Question number 5 is compare your critical Reynolds number with the theoretical value at which the transition from laminar to turbulent flow. What are the most significant reasons for the difference between the two? It is also if the Reynolds number based on pipe diameter is less than 2100, is called the flow is laminar. If it is less than 4000, is called the flow is turbulent. The Reynolds experiment establishes the three Reynolds number for pipe flow at which laminar flow Reynolds number decrease to 1000 is called transition to transitional, and 2000 decrease Reynolds number and decrease to 4000 is called transitional fluid transition to turbulent. Our Reynolds number is greater than 4000 in our experiments, indication that turbulent water occurs along the pipe. Okay, this is all from me. Thank you.
For our conclusion, first is practical and experiment result differ. Second is the sensor inability to receive information from fluid motion. The third one is learn about fluid movement in pipe using spray, elbow, 90 degrees and 45 degrees pipes. The fourth one is based on the data and graph, both theoretical and experimental head loss flow with velocity except for the elbow pipe. The fifth one is as Reynolds number increase, so does the friction coefficient. Theoretical and experiment calculation are used to determine which has the most heat loss. And the final one is finally, we determine the proper pipe size and type. Flow type also affect pipe loss. That's all from me. Thank you.